So I'm Thomas King, and I'm working on the OpenEEG project. And what an EEG basically is a bunch of electrodes on the scalp that measures brain activity. As you can see, this is obviously an extreme case where he's got probably 30 or so, most likely more. And then it just records all of the brain activity. And why do we want an open version? Well, the versions you just saw, they're very expensive. Mostly only like hospitals can get them, different research facilities. They're not portable, they come with big machines. And most importantly, they're not hackable. You can't go home and figure out how to make your own sort of like devices using these. So I thought, you know, it shouldn't be that hard. We can figure it out. Okay, basically how the brain works is it sends electrical impulses through neurons, and that's how sort of what happens when you think. So if you're thinking more in certain parts of the brain, it has more activity. Also, it functions in different wavelengths. If you have higher than like 14 hertz, you're very focused in that part of the brain, and so on. So the way you do it is you have certain points on the head. Right up there is the nose, and then that's the back of the head. And you put electrodes on it, and you can see the different voltages at different points. The problem is it's very small voltages on the order of like picoamp or picovolts. So basic circuitry as it is, you've got electrodes on that smiley guy over there that go through an amplifier and a filter to filter out all the noise that comes through the system, which then goes into a microcontroller. The microcontroller figures out approximate voltages, and then your computer analyzes it and makes a nice little display of the different ranges of frequencies that your brain is operating at and the different intensities of those frequencies. Something that I hope to do by the end of the summer is also add a wireless component. This is a dotted line that you can't see, but have one microcontroller that's farther away be able to wirelessly communicate with a microcontroller attached to the computer. So that's also in the works. So brainwaves come in different frequencies, and these are the 4 basic frequencies that are going to be displayed, their intensities. So you've got the delta, which is basically sleeping. You don't want any of these to show up if you're trying to like do hard working tasks or stuff. And then all the way down to beta, which is like very focused and awake. So you're gonna want to see a lot more beta if you're like doing a test or something. So there are a lot of different applications for this, some of which include like sleep analysis. Have you ever heard like you should sleep in 90-minute increments, like for your sleep cycles, so you don't wake up feeling like unrested? Well, with this, you could wear something at night and it would automatically figure out like when's the best time to wake you up. Rather than like, if I go to bed, say, at midnight, I'm like, okay, I want to wake up this time, but I don't actually get to sleep for 30 minutes. So then I'm like, okay, well I need to push my alarm over 30 minutes. And that just keeps me up worrying about that. Also, with meditation, it's found to be very, very good to have like a certain amount of like deep meditation time per day, so that you could do something that would track the amount of time that your brain is in like theta waves versus alpha waves while meditating, so you could get better at it. Also, there are a lot of educational games. A lot of like educational people are trying to push away from using medication to treat attention deficit disorder, and they're trying to push more towards brain training activities. So this is, if this will work, this is one of the ways that they're trying to do it. This is a game where you're trained by Yoda to be a Jedi, and the way it works is they have a small EEG on the person's head, and the more focused they are, the higher the ball goes, and there are many different levels. So what my project would do is allow it to be hackable. It would allow you to like create your own game for your own different things. This only focuses on beta waves on one point on the scalp, whereas with this you could choose where your different electrodes are and what type of waves you're focusing on, and instead of raising a ball, you could do whatever you wanted with it. So I'd like to say thank you to the usual suspects, Sean O'Sullivan, Goldschmidt, Morthy, and all the rest of you here at RCOS. Any questions? I'll start with you.
I wrote a paper on brain-computer interfaces, which is like what this is. And well, you know about the mechomemes or whatever, the badgers that work with how you think and whatnot. Are you like looking to just the monitoring sleep, or actual like game things that are like the big things, like virtual reality?
I'm mostly trying to like sort of strike a balance there, so it would work sort of both cases ish.
Okay.
Yeah. Yes.
I guess being Jerome proxy, I know that he would want you to use Bluetooth instead of a second microcontroller.
Yeah. Okay. I will definitely look into that then.
Yeah.
Yes.
Just out of curiosity, what's your progress so far?
My progress, I've gotten all the circuitry and stuff written out, and ordered, and while that's coming in, I'm working on the actual display and the like sort of going through the data. So hopefully by the time stuff comes in, that'll be ready and I'll be able to put it all together.
Yeah, I'm just remembering now that I also read that there is a wireless version of these brain-computer interfaces that they've had in like monkeys and pigs for 13 months, and it works in big plankton. So I don't know if anyone will look into something like that and see what they did there.
Yeah, I'll look into that. Anything else? Okay, thank you very much.